So kindly understand my situation too. I have met with one till accident. I'm coming to college, so I'm in work from home only today. So kindly cooperate with that. Then okay, I'll present the screen now. Only 44 members have joined. Kindly intimate your friends, remaining students, to join the session quickly. Okay, let they join. Can you see the screen? Yes or no, students?
Yes, ma'am.
Fine. So last class we were covering unit 3. Most of the previous topic, whatever you have covered, I hope you have at least gone through some information, at least know some related concept related with the topics what we have covered. Okay, so unit 3 consists of implications, establishing the architecture. So the first important half topic, அதாவது half unitல இருந்து கண்டிப்பா ஒரு questions வந்துரும். Important topic பார்த்தா implications and establishing the architecture. So if you are thorough with this either one topic, then you can very well attend the unit 3 questions in the final exam too properly. So today we will cover establishing the architecture, what we have left out. So last class we have started with establishing the architecture. So when you are working under product architecture team, what are the things you have to keep in mind, and what are the key points you have to remember that we have discussed last class. So at the end of this particular activity, establishing the architecture, what will be as an ideal input and output for us? We'll have an appropriate geometric layout of the product. So from the previous product development phase till that we have done planning, then concept selection phase, generation, then selection. In the selection there are two important types, screening and scoring. All those things we have covered. Then after finalizing, this is our concept, this is our product idea, then now we have to go for system level design, right? Any type of product. That is the workflow from for a entire product development phase. So when you are coming under product architecture phase, what will be the activity involved in this? We are going to create an geometric layout of the product. We are going to describe what are the chunks, parts, physical parts, what are the functionality to be given to each and every chunks. Those things we are going to finalize in this. Documentation of the key interactions among the chunks. Even though there are physical parts available for a product, what each and every part will be doing, what are the functionality. If two chunks have to be integrated together and do some functionality, everything will be in a documented fashion in this stages. Then 4 step involved for establishing the architecture, very important topic, important 60 mark question, frequently asked, so I can say as 13 marks also. Best example taken in your book is tested printer. So when you are considering this particular product and establishing the architecture, there are 4 step process used for decision processing. So first one is creating a schematic of the product, clustering the elements of the schematics, create a rough geometric layout, identify the fundamental and incidental interactions. Very important 4 subheadings. So last class we have covered any product. Here we have taken the example product is tested printer. So there we have identified what are the elements needed, what are the parts needed to create this particular product. So that is a step 1 process. Create a schematic of a product. Just wait, students. Schematic of a product. So we have understood for a tested product what are all the elements needed. So we have first created, we have found out what are the elements needed, and we have just scattered in this step 1 process. We have not clustered together, we have just understood what are the elements necessary for creating that particular product. From the beginning, like enclosing the printer, part have to be enclosed, a metal have to be, a metallic part should be enclosed, for the entire product. You have to provide a structural support for it, and for storing the paper and storing the blank paper, there should be a tray given, paper tray. All the elements have been identified in the step 1 process. Okay. Then in the step 1, they have identified what are the elements needed. So schematic of the desktop printer is shown in front of you, and they have understood what are the functional elements, what are the physical elements needed. Best example for physical elements or print cartridge. Okay. And for functional elements is store output. And for more some of the functions are not mentioned here full-fledged. Step 1 ல எடுத்த உடனே நம்ம எல்லா எலிமெண்ட்ஸையும் நம்ம சில டைம் represent பண்ண முடியாது. Some 2 or 3 may be left out. That only they have put here. Not all the connection among elements are shown in this step 1 process. But important elements are identified and they have listed, and they have mentioned with some representation. Dark line represent the flow of forces and energy needed between these selected elements. Flow of materials in a thin line frame. Dotted line represent the flow of signals on or data. So this you have to remember, the diagram you have to draw and see during your exams, preparation of exams. Step 1. Some points we have discussed is nothing but the startup of product architecture. We are going to draw a diagram. Whatever elements we have identified, we are going to draw as a diagram here. Why we have to represent as a diagram? To make the team understand the consequence of the elements in a particular product. Just wait, students. Then what will be the front end process? What will be the front out paper part? Everything will be understood through this diagram. Then what are the functional elements? What are the physical elements also will be identified here. And the best step 1, first of all, make the team best understand the state of a particular product. These are the key points what I have highlighted in front of you. The aim for when you are starting with step 1 process, we have to at least represent the elements, 30 elements in the schematics, less than 30 elements, 30 or less than 30. Not very less. You have to, maximum should be 30, minimum also it should be 30. For the purpose of establishing the product architecture. If you are going to consider any complex system, complex product, obviously there will be hundreds of functional elements and the physical parts for it. So in that you can avoid some minor ones and group some other into higher level functions, and again decompose later. Only in the case of complex systems. The point you have to remember. Then that's it. That is more enough for step 1 process. Functional elements we identify like control printer. So here control printer is considered as a functional elements. Here print cartridge is considered as physical elements. So it's a combination of both physical elements and functional elements. In the case of functional elements like control printer, it represented as a single centralized element as shown in the figure. How they represent how you can identify which is a physical element and which is a functional elements through this dotted lines. So flow of signals or data through that functional elements has been passed to the other elements present inside the product. Diagrammatic representation, the rules you have to follow, and what it denotes to the team, they have discussed in the points. So again, there should be some alternative would be to distribute the control of each of the other elements of the product throughout the system. So any part you are going to mention in step 1 process, you have to find out some alternative elements also. So generate several alternatives and several architectural optional. So I have already told, whenever you are learning each and every process under product development phase, you have to imagine that you are working under the team. So when you are working under product architecture team, when you are undergoing the step 1 process, just creating the schematic diagram is not enough for a particular product. You have to also imagine more alternative process. If one particular functional element fails, what will be the alternative functions to be make the product to run properly? So these also should be in your mind. Step 2 process, very simple, clustering the elements of the schematic. This also I have already discussed, as there is a long gap in these days. I'm just again recapping the session. After identifying what are all the elements in step 1 process, now we have to go for the step 2 in making the physical parts or functional parts which can be clustered together, which can be integrated together. Okay. When you go for grouping, then it is easy for us to make the product architecture more simpler way, as well as we are not going to make it complicated. Okay, we are going to integrate properly. And for following this cluster, I have already told clustering the elements is not an easy job. You have to keep many issues in your mind and then only group these elements. So what are the normal advantage in grouping these elements that we have seen last class? Okay. So what are all the elements have been grouped if you identified? Enclosed printer, provide structural support. These elements we have already found out in the step 1 process as a separate element. Now they have grouped into one and said to be clauses. Clauses means I have already told it's a metal part covering the elements. Next, again they have grouped as paper tray, where this functional element store output and store bank pay becomes a integrated one here. Similarly, positioning the cartridge in x-axis, positioning the paper in y-axis, pick paper, all together can be grouped as print mechanism. So in the step 2 process, they identify these elements can be grouped together and they have given a separate name for it. And here this physical element, print cartridge, which is easily replaceable, as you all know, the printer in print, that cartridge components is mostly used, frequently used component, so it should be easily replaceable. So they have separately grouped here. They have not combined inside the print mechanism. They have separated here. So understand, when step 2, in step 1 process, if you see, there will be 15 elements found. When we go for step 2 process, we have grouped into 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 separate clustering. Okay. Are you all following it? Kindly reply. Reply, students. Any doubt till now? Okay, fine. So kindly focus on these diagrams under unit 2 and unit 3. If you find, there will be a lot of diagrams present for each and every topic. You not write every information detailed. Diagram give more importance. Draw and see. Don't forget the inner part of the diagrams information. And what are the key points for each and every topic that you have to remember? In your own words, you can express it during the exams. Next. So what are the main challenge if you... Okay, here what are the points they have discussed is after making the clustering the elements of a schematic. Each and every cluster will yield a 15 chunk here. Yes, anybody has replied? I have. Okay, hostelers are attending the class in Hindi. Okay, no issues. Accordingly, you note down the attendance, Surya. Okay, managing the complexity of the alternatives is to begin with the assumption that each element of the schematic will be assigned to its own chunk, and then successfully cluster elements where advantageous. So you need not worry of these much of points. Just understand the diagram properly, draw it neatly. Then you can go for directly. While forming this type of clustering the elements, what will be the main advantage of any product? Like geometric interactions and precisions are given importance. Assigning elements to same chunk allows a single individual or a group to control the physical relationship among the elements. Okay. Now the best design will be as a part of same chunk when you integrate the parts. Then functional sharing. Single physical component can implement several functional elements. Then we say it's a functional sharing concept. Capabilities of vendors. This also I have already explained to you. When you go for when you're going to make a type of clustering, and you have to identify those capability vendors. இப்போ ஒரு வீடு கட்டும் போது ஒரே ஸ்மால் ஏரியால நம்ம டிஃப்ரெண்டா நம்ம திங்க் பண்ணியும் எல்லா பேசிக் நெசசரியும் நம்ம கொண்டு வரலாம். இட்ஸ் அப் டு த engineer plan or constructor vendors, we say suppliers or vendors. Similarly, ஒரு ப்ராடக்ட்டுக்கு ஒரு குறிப்பிட்ட பார்ட்ஸ்க்குள்ள இன்னும் நிறைய இன்டகிரேட் பண்ணா the parts will be what the appearance of the product also will be simple and very handy. So it's all up to you are choosing the vendor. So the trusted vendors may have specified capability related to your product here or project. In order to best take advantage of such capability, a team may choose to cluster those elements. So some best vendors, when you identify, they will give some ideas. So which are the parts can be integrated together, which will be more benefit in the functionalities can be got. So clustering will be helpful for us in that case. Simplicity of design and production technology. According to the updated technology, this grouping ideas can be made, and already made clustering idea will be helpful for the new technology. That's the point here. When two or more functional elements are likely to be implemented using the same design and production technology, then incorporating these elements into a same chunk may also allow for more economical redesign and productions. Okay. Localization of changes. If suppose you are depending on modular architecture, if you're going to replace some particular parts, that is not going to affect the other parts. So these are the things will be helpful when you go for clustering. Best example, so as we have a best clustering part here for desktop printer, as they have identified print cartridge is the frequent usage of component, they have separately given. They are not made into a particular group. So this type of idea, when there become a problem with the cartridge, it is easy for us to replace that particular part. Accommodating variety, clustering together. If best example HP printer, there are a lot of variety, like the printers can be used for students, office purpose, taking print photos. So accommodating variety, elements should be clustered together to enable the firm to vary the product in way that will have value for the customer. According to the customer demand, this by grouping these elements will be helpful. They tell like that. Enabling standardization. Obviously, when you give some variety, HP printer, there are 4 variety of printer, but the standard parts will be distributed throughout all the 4 variety. So set of elements will be useful in other products also. They should be clustered together into a single chunk. Portability of the interfaces. So interactions are easily transmitted over large distance. So when you are making this clustering part of any product, we will also analyze what type of energy you have to be depend on, like electrical signals are needed for your product or a mechanical force. So people will analyze accordingly and group the elements. They will find electrical signals are much more portable. So printer enga ponalo electrical provisions irundha, they can just connect that printer and take the printout, right? Instead of depending on mechanical force. The electrical interactions is best way they would have selected. But in all product you can't take that, right? As the printer is made up of most of the electronic products, the electrical signal is the best way. But in fluid connections, it will not suit. So accordingly, this clustering the elements becomes advantage to exist here. Step 3 process. So this is the thing we have left out. Step 3 is also very simple, students. In this step 3, we are going to create a rough geometric layout. As you hear the term geometric, you have to imagine 2D and 3D dimensional representation. This is 2D and 3D representation. So you can, when you are working under product architecture establishing team, establishing the architecture team, when you undergo the step 3 process, you will work on CAD tools, to find out the design of a layout of the product. The best example is shown in front of you. How will be a logical board appear in a product? What print mechanism should be fed in which part? This is the overall layout of the product. 2-dimensional here. So geometric layout can be created in 2 or 3 dimensions using a drawing or using a computer model, CAD tools, physical model like a molding, some physical part is given to it. Like a cardboard or foam, for example. So creating geometric layout, these are the key points you have to remember and you also want to write during your exams. Creating a geometric layout forces the team to consider whether the geometric interface among the chunk are feasible or not. Why we have to undergo the step 3 process? Till step 2, we have understood the real parts needed for a product, elements needed for the product, and what are the elements to be integrated, what should be represented separately. We have got an overall idea on step 2. And on step 3, we are going to full-fledged involved in giving a structure for a product, layout, geometric layout, how the product will look like at the final stage, but not full completed product, just giving a layout for it. Creating a geometric layout forces the team to consider whether the geometric interface among the chunk are feasible or not. அதாவது இந்த chunks எல்லாம் நம்ம இந்த மாதிரி கொடுத்தா it will be a comfortable for the product to run properly. ஒரு ட்ரேவே இந்த இடத்துல பிளேஸ் ஆனாதான் அந்த print mechanism will be done properly. So on the analysis, everything will be involved in this step 3 process. Creating a geometric layout force the team consider whether the geometric interface, whatever structure you are giving for the product among the chunk here or the parts, whether it's feasible, and to work out the basic dimension relationship among the chunk. If one chunk is dependent on other chunks, through this layout only you can find it out. In this step, as in the previous step, the team benefits from generating several alternative layout and select the best one. இதுலயும் நிறைய rough works பண்ணுவாங்க. They will do some which will be the best layouts. They will find it out, then only they will select in that. 2 or 3 alternatives they will do, structuring they will do, layouts they will give, and then select one which is the best for the product. So layout decision criteria are closely related to the clustering issues in step 2. So when you undergo step 3, if you want to make the step 3 success, then step 2 process should be done in a successful manner. Clustering the elements should be identified properly and should be framed in such a way. This will only helpful for us for a step 3 process to be a successful one. So the team may discover that clustering derived in step 2 is not geometrically feasible, that sometimes the elements would be reassigned to other chunks. Clustering ஏதோ problemனா again you have to make that step 2 properly done and then only you have to again move to step 3. So creating the rough layout should be coordinated with the industrial designer, very important. இப்போ நீங்க ஒரு ஆப்பிள் கம்பெனில ஒர்க் பண்றீங்க, சாம்சங் கம்பெனில ஒரு ஸ்மார்ட் போன் கம்பெனில ஒர்க் பண்றீங்க. You are a industrial designer. Who are the industrial designer? Apple parts and the physical appearance will be following a particular standard. That standard along with the architectural design should be what? Coordinated together. Okay. So rough layout should be coordinated. So என்ன மாதிரி functionality, physical parts நீங்க கொடுக்குறீங்களோ, that should be parallelly communicated with the industrial designer. You have to discuss with the industrial designer and create the rough layout for the step 3 process. So who are the 2 persons involved for step 3? You have to give a rough layout along with the coordination with the industrial designer on the team in case where you want to focus on aesthetic. What do you mean by aesthetic? The appearance, okay, the visual appearance, the beautiful appearance of a particular product depend on both the industrial designer and the product architecture. So laptop நீங்க யூஸ் பண்றீங்க, how that appearance has come both by product architecture team as well as the industrial designer team. So where the aesthetic and the human interface issues of the products are very much important and strongly related to the geometric arrangement of the chunk. So whenever you undergo the step 3 process, whenever you're going to create any rough geometric layout of for any product, you have to keep these things in your mind. When you give a 2D or 3D structure for the product, the step 2 have to be completed properly. If there is an issue in clustering the elements, then automatically it will be a great impact in step 3. So this should be clear enough to go for the step 3 process. When you are undergoing the step 3 process, again the other thing you have to keep in mind is you have to have a good coordination within the industrial designer team. Step 4, last step under establishing the product architecture. You have to identify the fundamental and incidental interactions. ஒரு ப்ராடக்ட்டுக்கு ஒரு ஆர்கிடெக்சர் டிசைன் கொடுக்குறீங்க அப்படின்னா, these are the steps you have to keep in mind. You have to identify what are the fundamental primary need என்ன, secondary need என்ன. Like what are the how to identify the fundamental interactions and the incidental interaction. Very simple. ஒரு பிரிண்டரோட மெயின் ஃபண்டமெண்டல் டியூட்டி என்ன? ஒரு பேப்பர் வச்சா through print mechanism it should print the informations in the white paper and it should display for us. Okay, that is a normal procedure. This is a fundamental idea. Printer na or fundamental, laptop na or input கொடுத்தா output monitor. So what is a fundamental thing? What are the incidental interactions? Logical, okay, functionality. That only we are going to cover in step 4 process. So you have to draw this diagram in your exam. They have only given the diagram for incidental interaction graph. So when you are working under step 4 process, you imagine you are a team member working for step 4 process. You are going to identify the fundamental and incidental interaction for the diskjet printer. So you have to draw a incidental interaction graph. So before going for this diagram, first understand what are the two categories. This is a 2 marks asked in your exam. 2 category of interaction between chunks. Chunks na உங்களுக்கு என்னன்னு தெரியும், elements or parts identified for a product. Fundamental interactions na என்ன புரிஞ்சுக்கணும். Are those corresponding to the lines on the schematic. Schematic naவே elements, lines of the elements that connect the chunk to one another. ஒவ்வொரு பார்ட்ஸும் எப்படி கனெக்ட் ஆயிட்டு ஒரு ஃபங்க்ஷன் நடக்குது ஒரு ப்ராடக்ட்குள்ள. ஃபார் எக்ஸாம்பிள், for a diskjet printer product, what is the fundamental interaction will be? A sheet of paper flow from the paper tray to the print mechanism. Correct? Is the fundamental primary need for a particular product. The interaction is planned. Or printer na இதுதான் plan. அப்பதான் இது printer னு சொல்லுவாங்க. A sheet of a paper flow from a paper tray to the print mechanism. This is the fundamental interaction. This is the interaction is planned here and should be well understood. Okay, even from the very earliest schematic. ஒரு எலிமெண்ட்ஸ் ஐடென்டிஃபை பண்றதுக்கு முன்னாடியே ஒரு பிரிண்டர் பண்ற பேசிக் ப்ராப்பர்ட்டி என்ன, பேசிக் மேனரிசம் என்னன்னு தெரிஞ்சுக்கணும். as it is a fundamental to the system operation. Are you all getting my point, students? Say yes or no. Are you all listening?
Yes, ma'am.
Yes, ma'am. Second, incidental interaction. Fundamental na okay, நீங்க இது தெரிஞ்சிட்டாவே போதும். இந்த லைனை எக்ஸ்பிளைன் பண்ணிட்டு எக்ஸாம்பிள் எக்ஸ்பிளைன் பண்ணிடுங்க. நெக்ஸ்ட், செகண்ட், இன்சிடென்ஷியல் இன்ட்ராக்ஷன்ஸ் ஆர் தோஸ் தட் அரைஸ் பிகாஸ் ஆஃப் அ பர்டிகுலர் பிசிக்கல் இம்ப்ளிமெண்டேஷன் ஆஃப் ஃபங்க்ஷனல் எலமெண்ட்ஸ். இப்போ உங்களுக்கு தெரியும் ஒரு ப்ராடக்ட்னாவே இட் இஸ் மேட் அப் ஆஃப் போத் பிசிக்கல் எலமெண்ட்ஸ் அண்ட் ஃபங்க்ஷனல் எலமெண்ட்ஸ். அப்போ இன்சிடென்ஷியல் இன்ட்ராக்ஷன்ஸ்னா என்ன இருக்கும்னா, ஏதாவது ஒரு பிசிக்கல் இம்ப்ளிமெண்டேஷன் ஆஃப் ஃபங்க்ஷனல் எலமெண்ட்ஸ் ஆர் ஃபவுண்ட் பிகாஸ் ஆஃப் ஜியோமெட்ரிக் அரேஞ்ச்மெண்ட் ஆஃப் சங்க். ஒரு லே அவுட்ல ஒரு பார்ட்ஸ்குள்ள ஒரு ப்ராப்ளம் ஆயிருக்கு. ஓகே, like example, vibrations induced by the accumulator in the paper tray could interfere with the prescribed location of print cartridge in the x-axis. இதுதான் இன்சிடென்ஷியல் இன்ட்ராக்ஷன்ஸ். ஒரு வைப்ரேஷனால ஏதோ ஒரு ப்ராப்ளம், ஒரு பிசிக்கல் இம்ப்ளிமெண்டேஷன் ஆஃப் அ பிசிக்கல் எலிமெண்ட்ஸ் ஆர் ஃபவுண்ட். அப்ப ஆட்டோமேட்டிக்கா அந்த ஒரு எக்ஸாசிஸ்ல தான் ஒரு பிரிண்ட் கேட்ரேஜ்ல ஒரு ப்ராப்பர் பிரிண்ட் வரும். ஒரு வைப்ரேஷன் அக்கர் ஆகிறதால என்ன இம்பாக்ட் ஆகும்? அதுதான் இன்சிடென்ஷியல் இன்ட்ராக்ஷன்ஸ். ஸோ ஃபார் எனி ப்ராடக்ட் யூ ஹாவ் டு ஐடென்டிஃபை வாட் ஆர் த ஃபண்டமெண்டல் interactions, what are the incidental interactions. Example, so overall printer oda mechanism la they have found out incidental interaction through a graph representation. இப்போ enclosure nu ஒரு part இருக்கு, paper tray nu ஒரு part இருக்கு. Each and every elements will be what connected together for any product to be run. Okay, ஸோ இங்க பார்த்தா ஒரு ஸ்டைலிங்னா ஒரு அப்பியரன்ஸுக்காக தான் இது ரெண்டுமே டிபெண்ட் ஆகுது. ஸோ அதுதான் இன்சிடென்ஷியல் இன்ட்ராக்ஷன். இப்போ பார்ட்ஸ் உடஞ்சிச்சுன்னா what will be the impact? That is incidental interaction. Similarly, paper tray and printing mechanism are connected together. If you are placing a paper in a paper tray and if you find some incidental interaction between these two parts, that's the point here. Through this incidental interaction are those that arises because of a particular physical implementation of functional elements. As you know, paper tray la வந்து store output ஒரு functional mechanism depend பண்ணிருக்கு. அதே மாதிரி print mechanismலயும் ஒரு functional elements depend பண்ணிருக்கு. Like what is the print mechanism part we have identified? Like positioning the cartridge in x-axis, positioning the paper in y-axis. So, ஒரு functional elements depend ஆகுது. If any between these two chunks, if any vibration occur, so what will be the impact found? That also have to be analyzed when you are going to create any product architecture. That's the point, students. So, step 4 is the thing involved in identifying the fundamental and incidental interaction. Fundamental are those what are the why the product is used, what is the main purpose of it, what is the fundamental activity performed by the product. Like a sheet of a paper flow from a paper tray to the print mechanism will be done. It's the fundamental action. In incidental interactions, as there are, the products is made up of many chunks and each and every chunks are connected together. If anything arises because of a particular physical implementation of a functional elements or because of geometric arrangement of a chunk, okay, like vibrations induced by the actuator, கொஞ்சம் processல ஏதோ ஒரு impact ஆகுதுன்னா in the paper tray could interfere with the prescribed location of the print cartridge in the excess. You would have found out ஒழுங்கா print mechanism நடந்துட்டே இருக்கு. ஓகே, ஒரு பிரிண்டர் புதுசா வாங்குறீங்க, பேப்பர் ட்ரேல பிளேஸ் பண்றீங்க, பேப்பர் நிறைய டாக்குமெண்ட்ஸ் எடுத்துட்டு இருக்கு. இன் பிட்வீன் டியூ டு ஃப்ரீக்வெண்ட் யூசேஜ் ஆஃப் அ பர்டிகுலர் பார்ட் ஆர் சம் வைப்ரேஷன்ஸ் அக்கர் டியூ டு ரெண்டு சங்க் இன்ட்ராக்ட் ரொம்ப ஆகி ஒரு ப்ராப்ளம் ஆகுதுன்னா automatically when you document, if you see there will be a dark lines found or some vibration sound may occur due to frequent usage of two chunks. So that also should be identified for any product. So in step 4 process, both functional interactions and incidental interactions are identified, and for all products this incidental interaction graph will be created. For diskjet printer they have shown enclosed and paper tray styling is the incidental interaction found. Most of this two chunk this vibration will occur. So these are identified here and represented as a graph. Similarly, print mechanism and logic board, both chunks are connected together. They have found thermal distortions occur frequently. Similarly, logic board and clauses, overall part, a metal part, thermal distortions or RF shieldings, uh, incidental procedure occur here. RF interfaces between logic board and power cord and brick. So this is how you have to identify for any type of product you are going to design what will be the incidental interactions, and you have to represent in a graph. So fundamental interactions are explicitly represented by the schematic showing the clustering of the elements into chunks. Incidental interactions must be documented in some other way, like what are all the problem occur when two chunks are connected together. So this is some other different procedure when compared to fundamental interactions. Here you have to represent incidental graph when you consider incidental interactions. For a large system, இது வந்து ஒரு simple productக்கு ஒரு simple incidental interaction graph they have drawn. When you want to represent incidental graph in the case of large system, it is not possible. So it will be a little confused when you consider a large system or a large product. So what they tell, you have to frame an interaction matrix is useful instead of graph. Can be used to display both fundamental and incidental interaction. Simple keywords, simple for you to understand, and you can understand this keyword and write in the exam properly. இது ரொம்ப தலையில போட்டு போயிடும் இந்த points. What they generally say is, as there are two categories are involved for any product, you have to identify both fundamental interactions and incidental interaction. What they tell in these points is, while undergoing the step 4 process, the team members should be assigned in such a way the mapping of interactions between chunks to provide the guidance for structuring and managing remaining the development activity. And those chunks with important interactions should be designed by groups with strong communication and coordinations. So team members should be assigned to create these fundamental chunks as well as interaction chunks. Then only we can identify the graph properly. Okay. So this is just assigning the members for doing this activity. So chunks with little interactions can be assigned by group with less coordinations. So for example, இந்த ஒரு ப்ராடக்ட்டுக்கு இதுதான் ஃபண்டமெண்டல் இன்ட்ராக்ஷன்ஸ் அப்படி ஐடென்டிஃபை பண்ணிட்டேன்னா அதுக்கு ஒரு ஸ்மால் குரூப்பை நம்ம ஃபைண்ட் அவுட் பண்ணி இதுக்கு அவங்க ஸ்டெப் எடுக்க வச்சிடலாம். ஜஸ்ட் அசைனிங் த செப்பரேட் குரூப் ஃபார் இட். When you consider incidental interactions, as you are able to identify what will be the impact in two chunk, obviously there will be one term analyzing this type of chunk and another team representing paper tray chunk representation. So when these two team coordinate together only, they can rectify, they will find out this will be the impact when two chunks are built inside a product. So அப்போ ஆட்டோமேட்டிக்கா இங்க கோஆர்டினேஷன் தேவைப்படுது, communication between the teams. So chunks with little interactions can be designed by group with less coordination. It is also possible through careful advanced coordinations to develop two interaction chunk in a complete independent fashion. But in the case of two chunks can be reduced in advance to a complete specified interaction interface that will be implemented by both chunks. So a relatively straightforward to specify interface to handle the fundamental interaction, but it can be difficult to do so for incidental interactions. You have to know the difference. Fundamental interactions ku நம்ம அந்த அளவுக்கு coordination தேவைப்படாது. But when you are going to depend on incidental interaction, a step 4 process, teamwork and coordination should be to find out the problems faced arises during a particular physical implementation of any functional elements inside a product. I think you are able to understand the difference between fundamental interactions and incidental interaction. The knowledge of incidental interactions develop a system level and detailed design process. ரொம்ப important point. நம்ம சொல்றோம் எந்த ப்ராடக்ட்டுக்கும் நம்ம ரெண்டு கேட்டகரியா பிரிக்கணும். ஒரு ப்ராடக்டோட ஃபங்க்ஷனல் ஃபண்டமெண்டல் இன்ட்ராக்ஷன்ஸ் என்ன, ஒரு ப்ராடக்டோட இன்சிடென்ஷியல் இன்ட்ராக்ஷன்ஸ் என்னன்னு. So when you find out this incidental interaction for any product, it will impact the system level and detailed design process. So you have to know the difference between system level and detailed design. என்ன மேம் the system level? Very simple. For any product, you have to understand what is system level design. So high level of abstractions is a system level where the functionality is described using a system level specification. Like in the case of VLSI design வச்சுக்கோங்க, ஏதோ ஒரு ப்ராடக்டோட டிசைன். So describing about the processor, memories. ஒரு VLSIனா என்னென்ன இருக்கும்? பேசிக்கா ஃபண்டமெண்டல்ஸ் என்ன? ஒரு ப்ராசஸர் இருக்கணும், ஒரு மெமரி இருக்கணும், எக்ஸெட்ரா மெனி டீடைல்ஸ் வில் பி தேர். இன்னொரு எக்ஸாம்பிள் கூட இங்க இருக்கு பாருங்க. சிஸ்டம் டிசைன்னா ப்ராசஸ் ஆஃப் டிஃபைனிங் த ஆர்கிடெக்சர், ஒரு ப்ராடக்ட் டிசைன், மாடியூல்ஸ், இன்டர்ஃபேஸ் அண்ட் டேட்டா ஃபார் அ சிஸ்டம். அதுதான் ஃபண்டமெண்டல். ஒரு ப்ராடக்ட் ரன் ஆகுறதுக்கு எப்படி இப்போ டெஸ்க்டாப் பிரிண்டருக்கு ஃபண்டமெண்டல் வந்து ஒரு பேப்பர் ட்ரேல பேப்பர் ப்ராசஸ் போயிட்டு பிரிண்ட் மெக்கானிசம்க்கு போகுதோ அதே மாதிரி தான் சிஸ்டம் லெவல் டிசைன் ஃபார் எனி ப்ராடக்ட். வாட் வில் பி த ப்ராசஸ் ஆஃப் டிஃபைனிங் த ஆர்கிடெக்சர்? ப்ராடக்ட் டிசைன் என்ன, மாடியூல்ஸ் என்ன, டேட்டா ஃபார் சிஸ்டம் டு சாட்டிஸ்ஃபை த ஸ்பெசிஃபைட் ரெக்வயர்மெண்ட்ஸ். ஸோ சிஸ்டம் டிசைன் could be seen as a application of the system. So printer எதுக்கு அப்ளை பண்றோம்? ஒரு பிரிண்டர் எதுக்கு நீட்? ஒரு டாக்குமெண்ட் எடுக்கிறதுக்கு, ஒரு பிரிண்டட் டாக்குமெண்ட் எடுக்கிறதுக்கு. ஸோ தட் இஸ் டு பி சிஸ்டம் லெவல் டிசைன். அப்போனா டீடைல் லெவல் டிசைன்னா என்ன? டீடைல் லெவல் டிசைன் மீன்ஸ் மோஸ்ட் டீடைல்டு டெக்னிக்கல் டாக்குமெண்ட் விச் டிஸ்கிரைப்ஸ் யூசர் ஸ்டோர்ஸ். ஏதாவது எரர் ப்ராசஸிங் அல்காரிதம் அதெல்லாம் ஃபீட் பண்ணாதான் உங்களுக்கு புரியுதுன்னு நினைக்கிறேன். ஒரு பிரிண்டர்ல ஏதாவது ஒரு ப்ராப்ளம் அரைஸ் ஆகுது, அது உங்களுக்கு சாஃப்ட்வேர் மூலமா மானிட்டர்ல டிஸ்பிளே ஆகுது, கரெக்டா? யூ ஹாவ் டோன்ட் இன்சர்டட் எனி பேப்பர், அதாவது பிரிண்டர் நீட் அ பேப்பர் அப்படின்னு அந்த அந்த மெக்கானிசம் சொல்றது தான் இன்சிடென்ஷியல் இன்ட்ராக்ஷன். கேன் யூ அண்டர்ஸ்டாண்ட் த டிஃபரன்ஸ் பிட்வீன் ஃபண்டமெண்டல் அண்ட் இன்சிடென்ஷியல் இன்ட்ராக்ஷன் ஸ்டூடெண்ட்ஸ்? ஃபண்டமெண்டல்னா ஒரு ப்ராடக்ட் எதுக்கு யூஸ் பண்றோம், இந்த யூசேஜ் அப்ளிகேஷன் என்ன. அதே இன்சிடென்ஷியல் இன்டராக்ஷன் டிஸ்கிரைப் அபவுட் த டீடைல் லெவல் டிசைன். ஏதாவது ஒரு ரெண்டு சங்க் பிட்வீன்ல ஏதாவது ப்ராப்ளம் அரைஸ் ஆனா ஒரு எரர் ப்ராசஸிங் அல்காரிதம் மூலமா அவங்க ப்ரோக்ராமிங் செட் பண்ணதால தான் உங்களுக்கு அந்த ப்ராப்ளமா ஐடென்டிஃபை பண்ண முடியும். ஸோ யூ ஒர்க்கிங் அண்டர் ஸ்டெப் 4 process in identifying the fundamental and incidental interactions, you have to know the difference between system level design and detail level design. But detail level design mostly deals about what? Detailed technical document. இப்போ உங்களுக்கு புரியுதா இந்த லைன்? Detailed technical document இல்ல சொல்லிருப்பாங்க பாருங்க. Fundamental interactions are those corresponding to the lines on the schematic that connects the chunks to one another. அதே வந்து incidental interactions are those that arise because of a particular physical implementation of functional elements on or because of geometric arrangement of the chunk. இப்போ எரர் ப்ராப்ளம் ஏதாவது ஐடென்டிஃபை பண்றது தான் இது இந்த interactions. So fundamental interaction tells about the system design, whereas incidental interaction tells about the detailed design. Okay, detailed design. Detailed design. இங்க இருக்கு பாருங்க பாயிண்ட். Used for documenting this information as it evolves. So what is that type of documentation here? I have told you in this point. So detailed design, which tells about the incidental interactions, describe as the technical document which describes the user stores, error process algorithm, state transition, ஒரு chunk to another chunk ரிலேட் ஆகும்போது என்ன டைப் ஆஃப் டிரான்சிஷன் நடக்குது, லாஜிக்கல் சீக்வன்ஸ், அதர்ஸ். ஓகே, இட்ஸ் a major difference. கொஞ்சம் லைட்டா கன்ஃபியூஸ் ஆகிற மாதிரி தான் இருக்கும். நீங்க இம்பார்ட்டன்ட் மட்டும் நீங்க மைண்ட்ல வச்சுக்கோங்க. ஃபண்டமெண்டல் இன்ட்ராக்ஷன்னா அப்ளிகேஷன் ஓரியன்டா, எதுக்கு அந்த ப்ராடக்டை நம்ம யூஸ் பண்ண போறோம், வாட் இஸ் அ ஃபண்டமெண்டல் திங் இன் யூசிங் தட் ப்ராடக்ட், அப்ளிகேஷன் எங்க. ஓகே, இன்சிடென்ஷியல் இன்ட்ராக்ஷன்னா நிறைய சங்க்ஸ் எல்லாம் இன்ட்ராக்ட் ஆயிருக்கு உள்ள ப்ராடக்ட்குள்ள, அதில் ஒரு சங்குக்கும் ஏதாவது ஒரு ப்ராப்ளம் அரைஸ் ஆகுதுன்னா என்ன மாதிரி அவுட்புட் வரும் லாஜிக்கலா? ஓகே, இன்சிடென்ஷியல் இன்ட்ராக்ஷன் லைக் வைப்ரேஷன் இன்டியூஸ் பை த ஆக்குலேட்டர் இந்த பேப்பர் ட்ரே வுட் இன்டர்ஃபியர். ஸோ அதை ஐடென்டிஃபை பண்ணுறதுக்கு ஒரு குரூப் இருப்பாங்க. இது எந்த ப்ராடக்ட் எடுத்துக்கிட்டாலும் இந்த 2 category will be followed up in step 4 process. So there will be a group for identifying the fundamental interaction for a product, and also there will be a group for identifying the incidental interactions of a product. So when you are undergoing incidental interaction, you are going to draw an incidental interaction graph in a small product. If it is a complex product, we are going to depend on incidental interaction matrix. Okay? So that's it. So I think you have understood what is system level and the detailed design process. The terms la neenga day to day life la neenga go neenga even if you get placed in a company, you have to understand these terminology, because this PDD subject will be lifelong, will be covering in your lifetime. ஒரு ப்ராடக்ட் நீங்க பர்ச்சேஸ் பண்ணா கூட இதெல்லாம் உங்களுக்கு தெரிஞ்சுக்க வேண்டிய விஷயம் தான். Similarly, when you are going to undergo any final year project also, this is the same procedure you are going to follow. Even if you are going to work in a company also, you are going to work under an architecture team or a design team or an implementation team. So this is not going to be a waste of time. So kindly understand the difference between system level and the detailed design process. Then there is a particular terminology here given, system architecture. So system architecture is as a whole tell about a network of interaction among subsystem, modules and components, and sometimes called a system architecture. So product architecture is said to be, it's made up of subsystems, modules and components. Okay, what's time now? 10:40 ஆயிடுச்சுங்களா? Okay, this question is also asked for your exam students. Related system level design issues. இதுக்கு வேணா நான் ஒரு வீடியோ கிளிப்ஸ் அனுப்புறேன், அண்டர்ஸ்டாண்ட் பண்ணிக்கோங்க. டுடே ஆல்ரெடி இட்ஸ் டைம். இது என்ன டாபிக் அப்படின்னா, ஐ ஹவ் ஆல்ரெடி டோல்ட் இன் ஸ்டெப் 1 ப்ராசஸ். இன் ஸ்டெப் 1 வாட் வி ஹவ் சீன், கிரியேட் அ schematic of the product. In this இங்கேயே பார்த்துருப்போம். In this representation, they have listed the functional elements and physical elements. For clarity, not all connections among elements are shown. கரெக்டா? இந்த வேர்ட் வந்து ஒரு ப்ராடக்ட்டுக்குள்ள இருக்க எல்லாத்தையும் நம்ம இதில் ரெப்ரசென்ட் பண்ணலன்னு சொல்லியிருக்கோம். ஸோ வாட் ஆர் த திங்ஸ் லெஃப்ட் அவுட் இஸ் பீன் டிஸ்கஸ்ட் இன் திஸ் லாஸ்ட் டாபிக். ரிலேட்டட் சிஸ்டம் லெவல் டிசைன் இஷ்யூஸ். What is related system level design issues? Now, 4-step method for establishing the product architecture guides the early system level design activity, whatever we have covered till now. Creating, clustering, then rough layout, then identifying the fundamental interactions and incidental interaction, establishing that. So, but many more details activities remain. So, what are the remaining thing that is being listed here? அது ஒன்றும் இல்லை. செகண்டரி சிஸ்டம், எந்த ஒரு ப்ராடக்ட் எடுத்துக்கிட்டாலுமே we have to focus on safety system, power system, status monitor and structural support. This is acting as a secondary system. I'll send you the video related with this topic to understand. Today it's enough. Then establishing the architecture of the chunk, some dozens of parts. For example, print cartridge na அதுக்குள்ள பார்த்தா sub functions இருக்கும். Like ink storing, delivering the ink for each of the 4 colors of ink. So these are the left out chunks which is not discussed in the previous establishing the product architecture, which comes under related system level design issues. Creating detailed interface specifications அதே தான். For example, இந்த மாதிரி ஒரு black print cartridge is connected to a logic board னு வச்சுக்கோங்க. எப்படி கனெக்ட் ஆயிருக்கும்? அதுக்கு ஒரு ஐடியா. There will be this is the specifications. Like you can imagine like a wire or some wire with the programming set. So one will represent power cord of A with the properties, and power cord of B with this property, This is the in-depth detail about a particular chunk connected to the other chunk. So these are the other related system level detail issues you have to keep in mind, and you have to identify what are the secondary system needed for the product, what are the in-depth sub-functional functions needed for each and every chunk, and specifications. அந்த பார்ட்ஸுக்கு சில ஸ்பெசிஃபைடு ப்ராப்பர்ட்டிஸ் நம்ம யூஸ் பண்ணோம் இல்லையா, அதெல்லாம் இருக்கும். அவ்வளோதான். I'll send this alone the video. Any doubt till now, students? So I will, after sending the related video, you go through today itself. Even though you will prepare for microprocessor and understand, I'll send this document to you for learning PDDPA. Can you see the document, students? Say yes or no?
Yes, ma'am.
Yes. Question with answer. Your friends have helped me in getting the questions. I have just left out with few alignments. I'll properly align and circulate in the class group. Read this question alone. I don't know which set you will get. Set 1 and set 2 combined தான் வச்சு அனுப்பியிருக்கேன். So at least be thorough with these 10 questions, okay? இதுல இருந்து தான் questions வரும். Any other doubts if you have, you can ask me in personal. Okay, we'll see on Wednesday. Okay, அதுக்குள்ள இதை அலைன் பண்ணி உங்களுக்கு சர்க்குலேட் பண்றேன். Thank you students for patiently listening. You can leave the session. Jayasura, kindly send the absentees list.
Yeah, ma'am. Thank you, ma'am.
Thank you all.
Thank you, ma'am.
Thank you. Fine.